Crikey, you're going to come down under with me now, mates, as we look at negative exponents. And pretty soon you'll understand why I'm talking about down under. Let's talk a little bit about exponents in general. First of all, we can understand that if I were to take an expression like this, 10 to the third, and then divide it by 10 squared, I could try and simplify this by breaking it down into factors, right? 10 to the third is 10 times 10 times 10, and 10 to the second is 10 times 10. Now, of course, I could start eliminating these things, and in the end, how many tens am I left with? Well, of course, you would say 1. And now we understand where 1 to the first, 10 to the first comes from. All right, mate. Sorry about that background noise. Can't promise you it's going away. She's only a couple years old. Loves to talk. Moving on. Now we'll get into 10 to the third over 10 to the third. As we break this down, we're starting to see, okay, crossing out, crossing out, crossing out. And we know that all of these just get replaced with 1s. And so in the end, we could say that 10 to the 0 power, because there's no powers left, is equal to 1. And in the end, we could really put this down. We could say A referring to any number to the 0 power, is always going to equal 1. Alright? So we can keep these things in mind as we continue marching along. Alright, let's move on to the next step. Well, what happens when we... Yeah, that's right. Come on down to Australia, the outback. Right? The down under. What happens when we have a larger exponent on the bottom? Suddenly we get here, right? Crossing out, gone. And we're left with this idea, 1 to the 10th. But how do you write that as a power? This is where our negatives come in. When we see this idea, a negative power, what we're really talking about is whatever that number is becomes your denominator. Interesting. So we kind of work like this, right? If I were to take a number, let's say A to the X, and I'll put a negative sign in front of it, so it's negative, that is really equal to 1 over A to the X. So for another example, right, if I had 10 to the negative second, that is really equal to 1 over 10 to the second, which would be equal to 1/100th, because 10 times 10 is 100. Alright, here's our negative exponents explanation. Here are 3 samples for you. Alright. Crikey, I think my accent's been changing back and forth between a little bit of country and a little bit of Australian. I'm going to have to work on that for next showing. But let's start working with, well, how do we put this in terms of scientific notation? Now, scientific notation isn't a new concept. We've worked with notation in the positive, and we understand that that positive means we're going to move over 5 to the right and get a really big number like this. So if we put it in the negative, right, it's just like working with a fraction, 10 to the whatever power. And so instead of moving our decimal to the right, we're going to move our decimal to the left. So if I start with my number 4 63 hundredths, and I want to move it -5, we're going to come away with an answer that looks like that. And once we get rid of all these super curls, well, should erase a little bit more, it looks like. Now it looks like I got 25 decimal points. But only one super decimal point. Alright. Now I'm talking German or Russian. I don't know. Here we go. We have this idea, right? Because 10 to the negative fifth is the same as 10 to the fifth, or 1, like that. And so we're going to move our decimal by that amount, right? We've talked about this when multiplying by power of 10s and dividing by power of 10. So this is where scientific notation connects with those power of 10s rules. So let's transform this number into scientific notation, right? Scientific notation, we know, of course, we have to move our decimal so that our decimal sits behind the first whole number digit. So it can't be a 0. Right. So I have to put a 4 there, and then of course it's going to be followed by however many digits are left. In this case, I just have my 5, so it's 4, 5. Now we're going to multiply by 10 to the negative something, right? Since we're moving it backwards. So we go negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And so by working through that, we come away with 4.5 times 10 to the negative 8th is how to express this in scientific notation. All right. Time for you to do a little comparing, making sure you're working with and understanding your scientific notation and your negative exponents. So go ahead and work through this. I can scoop these numbers a little closer if you don't know what that's trying to say. And we'll see you in class. Thanks for joining me down here in Australia, mate. Or maybe I was just in Texas and I'm losing my Australian accent. Or maybe I'm just a horrible actor. Well, whatever. Next time.